sklearn, neighbors, radius neighbors classifier. Description: a classifier that implements radius-based nearest neighbors search. It predicts the class of a data point based on the majority class among its neighbors within a specified radius. Inputs: X training data, where each row represents a data point and each column represents a feature. Y target labels for the training data. Outputs: predicted class labels. The predicted class labels for new data points based on the learned neighborhood structure. Probabilities optional. The probability of each class for new data points. Steps: training. The model learns the neighborhood structure of the training data by storing all data points and their corresponding labels. Prediction for a new data point. The model finds all training data points within a specified radius. It then predicts the class of the new data point based on the majority class among its neighbors. Metrics: accuracy, the percentage of correctly classified data points. Precision, the ratio of true positive predictions to the total number of positive predictions. Recall, the ratio of true positive predictions to the total number of actual positive instances. F1 score, a harmonic mean of precision and recall. Visualization plots. Decision boundary plot visualizes the decision boundary learned by the model. Neighborhood visualization visualizes the neighbors of a specific data point. Fine-tune parameters. Radius, the radius of the neighborhood to consider for predictions. Weights, the weight function to use for neighbors, e.g. uniform. Distance. Algorithm, the algorithm to use for neighbor search, e.g. brute. KD tree. Ball tree. Uncertainty methods. Confidence score, the probability of the predicted class. Number of neighbors, the number of neighbors within the specified radius. Challenges and fixes. Challenge 1: choosing the optimal radius. A radius that is too small may result in few neighbors, leading to inaccurate predictions. A radius that is too large may include irrelevant neighbors, also leading to inaccurate predictions. Sample use case that resulted in challenge 1: a model with a small radius failed to predict the class correctly for a new data point that was located close to the decision boundary. Fixes to challenge 1: experiment with different radius values to find the optimal balance between including enough neighbors and avoiding irrelevant neighbors. Challenge 2: handling imbalanced datasets. If the data is imbalanced, the model may favor the majority class. Sample use case that resulted in challenge 2: a model trained on an imbalanced dataset consistently predicted the majority class for new data points. Fixes to challenge 2: oversample the minority class or undersample the majority class to balance a dataset. Use a weighted loss function to penalize misclassifications of the minority class more heavily.